the application of CRISP-DM. Let's focus on a case that compared Airbnb pricing and listing trends from Los Angeles and New York from October 2018 to October 2019. And this author is Alexander Manson if you want to look at the study. Let's apply the CRISP-DM approach to the Airbnb pricing application. First, we ask what the purpose of this analysis is. And then we ask what a clear and crisp definition of the problem is. We look and ask if there are differences in the distribution of property sizes between Los Angeles and New York. Are there differences in pricing trends between the two cities? And are there differences in price spikes right around the weekend? The second phase is understanding the data. We need to determine what data is needed, collect it, explore it, and make sure the quality is high. In this particular example, we can go to a website that houses Airbnb data. Here's New York City. Let's go backwards in time a bit. This is May 2020, and we see several different data sets here. This particular one, when you open it and download it, it's in a CSV file. The Airbnb data was in a compressed file, and we decompressed it. It was a CSV, and so we've opened it into Excel. And we note that it is very raw. It's kind of messy and it's not ready to analyze yet. But that's a very common occurrence as you get raw data and then you get it set up so that you can analyze it. So this Airbnb data is raw and it's not ready to analyze. So let's go and see if we can get a better understanding of the data. There are two data sets that we're going to look at. The first one is calendar. So there's one for every day of the year. All 365 days for every property. So we have 32,232,620 entries. And there are 5 variables. 60% of the price entries are missing values. There's a non-normal distribution of prices skewed to the right with a lot of outliers above $20,000 a night. Additionally, we have mismatched dates between Los Angeles and New York where we have no listings at all. In the listings dataset, there are 93,804 entries, and that's 12 variables. So that's every place, location, or property that can be used in an Airbnb transaction. The experience offered feature is missing in all the values. The square foot feature is missing in most of those. Bathrooms, bedrooms, and the bed feature all are missing about 1.5% of their values. Again, the numerical features are right skewed with a lot of outliers at the far right end. There's a huge correlation between the number of people that a property accommodates, the number of bathrooms, the number of bedrooms and beds, which makes sense. Very large properties often have a lot of bathrooms and a lot of bedrooms and a lot of accommodations. We also note that there's a bit of an issue with string encoded amenities and they're fixed and they're mixed formatted. There's no consistency there. As we prepare the data, we will drop the mismatch dates between Los Angeles and New York. We'll drop listings that were not available for the entire time interval. We're going to drop super expensive listings above $20,000 per night because it makes our results not very accurate. And we will drop the columns or the attributes, experience offered and square foot features. Further, in data preparation, we'll drop listings for which the average listing price is not available. We'll drop 1.5% of listings with the missing numerical feature values, and we are going to create 2 bins. And this is the median listing price bin. One will be less than or equal to $564 and the other will be greater than $564. As we look at the modeling phase, sometimes graphics helps us to visualize the data to understand it. The first graphic here is accommodations. Blue is for Los Angeles, orange is for New York. This first violin plot is for median price less than or equal to $564. The second one is for greater than $564. So we note that there are a lot more entries, a lot more data points for more than $564. This one is for number of bedrooms. Then we have number of bathrooms and number of beds. So this is the violin plot to look at numbers of data points, again between Los Angeles and New York, and for less than and greater than $564. Here is some of the data in a tabular format as we look to further understand the data. Let's draw a line right down here. This left side is the median less and equal to $564. The right side here is greater than $564. So we get the number that we're looking at, the mean, and we're looking here in this first section of accommodations. So the mean is 3.48 people, the median is 3, the standard deviation is 2.35. So we calculate those same statistics for accommodations and then bedrooms and bathrooms. We see bedrooms, the mean is 1.29, the median is 1, and the standard deviation is 0.88. Bathrooms, the mean is 1.34, the median is 1, and standard deviation is 0.71. When we compare those, then to properties greater than $564, we have more accommodations, mean and median. We have more bedrooms, 3.83 to 1.29. We have more bathrooms with 3.73 as compared to 1.34 and 3.5 at the median. So we like to look at some of these comparisons and see if they make sense to us. Here is a daily pricing data in a chart format. Some of our findings are: the average Airbnb pricing and availability trends are similar between Los Angeles and New York, with some differences in the magnitude of price changes depending on the season. The other thing is that there's a 5 to 10% spike in the average prices on weekends, which is something that we would predict. This chart shows the average weekend price hikes for low price listings in Los Angeles is 1.5% higher than those in New York. So that's 5% to 3.5%. We have the same type of difference for high price listings, but it's only 0.1 price point. So as we do an evaluation, we noted that the difference between Los Angeles and New York City for low price listings, those lower or equal to $564, is statistically significant, while the high price listings is not statistically significant. Further evaluating, we could focus on weekend pricing, and we would eliminate fixed price accommodations so that we could concentrate on seeing how much the price goes up on weekends, so that we can determine if we're charging the right price. So we look at average weekend price hikes for non-fixed price listings for both cities, and in fact they are. The difference between Los Angeles and New York is also larger for these spikes, that's 7% to 4.9%, and in the high price bin it's 9.8 to 7.5, and again that's statistically significant. The deployment of this case is far simpler than something that was maybe an online model or predictive model where we might have some sort of dashboard. This deployment strategy had to ensure that the analysis was readable, reproducible, and maintainable. In this case, the requirements were met by generating a Jupyter notebook, detailing every step of the analytical process, documenting it, and justifying all the choices that were made. As we cleaned the data, made features, selected a model, and evaluation.